back in Algebra 2. We talked in the last section about maximum number of turning points. Remind me again, what's the maximum number of turning points of a polynomial? It's going to be what? One less than the degree. So there's another theorem out there which talks about the zeros. A polynomial function can have no more zeros than its degree. So if it's a third degree polynomial, it can have no more than 3 zeros. So remember, the number of turning points is 1 less the degree. Number of zeros has to be the same as the degree. So let's talk about how we can start solving these polynomial equations if none of my factoring techniques work. We have what's called the rational zero theorem. So this is a theorem that we can use to help us develop a list of possible zeros to the equation. I call this the P over Q test. Again, factoring doesn't work that I have. Grouping doesn't work, the cubes, difference of squares, etc. All those techniques of factoring doesn't work. How am I going to solve an equation if none of these factoring techniques work? One thing you're going to then try is you're going to use this rational zero. P is what we call the factors of the constant term. Remember, the constant term is the term that does not have a variable x with it. Q are the factors of the leading coefficient. Remember, the leading coefficient is going to be the number in front of the variable that has the highest power. And you're going to make a list of combinations. You're going to take all your factors of P, you're going to divide them by the factors of Q. P and Q, again, must be real coefficients. In other words, we're not dealing with those imaginary numbers anymore. So, for example, let's take a look at 6x to the fourth minus x squared plus 2. Again, these aren't going to tell me the zeros. This is going to tell me the potential, the possibilities. These are my candidates. All right? Some may be my zeros, some may not be. So P, remember, are the factors of my constant term. My constant term is 2. So now, tell me what the factors of 2 are. What numbers multiplied together give me 2? 2 and 1. Would you also agree with me that negative 2 and positive 2? Negative 2 can be a factor. Can negative 1 be a factor? So what we have to write is plus or minus 1, plus or minus 2. So you need to consider both the positive and the negative. Q are the factors of my leading coefficient. Remember, the leading coefficient is the number in front of the largest exponent for x. So what are my factors of 6? What numbers multiplied together give me 6? 3 times 2 and 6 times 1. So I have got 6. So 6 is my Q. Plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. So any questions on how I identified the factors of P or the factors of Q? Now I need to come up with my list, the P over Q. So I have to make my combinations. The way I start is I take one of my factors of P. So I'm going to start with plus or minus 1. And what you're going to do is you're going to make a whole bunch of fractions. You're going to take one of your factors of P, which in this case I'm going to start with 1. And I'm just going to make a bunch of fractions, having my denominator all the factors of Q. So plus or minus 1 over 1, plus or minus 1 over 6, plus or minus 1 over 2, plus or minus 1 over 3. I repeat the same process, except now I'm going to use my other factor of P, which is 2. So plus or minus 2 over 1. Plus or minus 2 over 6. By the way, what does 2 over 6 reduce to? 1/3. Don't I already have 1/3 in my list? So you don't need to repeat the same number twice. Remember, 2 over 6 reduces to 1/3. 1/3 is already in my list, so I don't need to write 2 over 6 or 1/3 again. 2 over 2. What does 2 over 2 reduce to? 1. Isn't 1 already in my list? Yes. And then plus or minus what? 2 over 3. So these are my list of possible rational zeros. So what you found is this. We haven't solved the equation yet, but when I do solve the equation, the only zeros to this equation have to be somewhere in this list. Not all of them are my zeros, but somewhere embedded in the list of numbers you created are my zeros. That's what you're stating. These are not, again, it's only a fourth degree polynomial, so at most I can only have 4 zeros. I've got a lot more in this list. So you just created a list of where the zeros could, what these zeros could possibly be. So now we're going to talk about how by this list, how I'm actually going to be able to find the actual zeros here in a moment. So really, when we want to go solving and finding the real zeros, we're going to make some thoughts, and we're going to make a possible list of zeros based on the graph and the list of potential zeros. What we're going to have to do to start finding the zeros, and you're going to test each potential zero by using, I should say rational zero, by using synthetic division. So the way you solve and how this list is going to help you is you're going to test each potential rational zero by using synthetic division. Each time a zero is found, thus a solution is found, we're going to repeat the steps on the depressed equation. And we'll talk about this depressed equation in a minute. We eventually want to get it down to a quadratic that we can factor before we use the quadratic theorem for. So before we get into doing all this steps, some things that we have to talk about. And you guys did this last year. You guys did not do the P over Q test, but you guys did talk about the remainder theorem. If you have a polynomial function, if f of x is divided by x minus c, then the remainder is 0. Okay? So in other words, what's going to happen? The way you know that x minus c or c is a 0, the remainder should be a 0, if indeed you've got a factor to this particular equation. If you do not get a remainder of 0, you know that the factor is not a part of that polynomial, and neither is the 0. So find the remainder. If x to the third minus 4x squared plus 2x minus 5 is divided by x minus 3. Can I do synthetic division? Yes, because I'm dividing by an x minus 3. So I'm just going to go ahead and use my synthetic division. The question's only asking me to find the remainder. If x minus 3 is my factor, what number goes in front of the synthetic division? 3. I'll line up the coefficients at the top, 1, -4, 2, and -5. Bring down 1. 3 times 1 is 3. -4 plus 3 is -1. 3 times -1 is -3. 2 plus -3 is -1. 3 times -1 is -3. -5 minus 3 is a -8. So what is my remainder? My remainder is just what? -8. Okay? So any questions on recognizing what the remainder is going to be? No, it's just asking what the actual remainder is. That's it. So what you know is that 3 is not a 0. 3 is not a solution. In order for 3 to be a solution, the remainder has to be a 0. All right, so that's what you know. You know that 3 is not going to be a solution to this particular equation. Factor theorem. It's kind of the reverse of the remainder theorem. A polynomial has a factor of x minus k if f of k is equal to 0. So if your remainder is equal to 0, then the factor x minus k is a factor of that particular polynomial. So the way we enter this question, is x minus 10 a factor? What would the remainder have to be if x minus 10 is a factor? The remainder would also have to be a what? 0. So go ahead and do your synthetic division and tell me whether or not is x minus 10 a factor?
Yes.
Yes. And again, the reason why is because the remainder is equal to 0. All right, so any questions on how you know whether or not a polynomial is a factor of another polynomial? You guys go ahead and try B for me. Remainder is not equal to 0. All right, so Any questions on how you recognize when a factor? All right, so now the question is, let's start factoring these polynomials. Always, always, before you go the long way, always see if your old factoring techniques will work. So does grouping work? Does GCX work? So when you take a look at example 4, you can try to group this first. Always try what you know first before you make the process a lot longer. So the way I would check grouping is, remember, you group together the first 2 terms, you group together the last 2 terms. So I can factor an x squared out of the first set of parentheses, and that gives me an x minus 13 left. The question is, can I take 108 and divide it by 24 evenly? No. So grouping is not going to work, unfortunately. So none of my existing factoring techniques is going to work. As long as you know 1 0 or 1 solution, and that's what they're giving you. They're giving you this k equals -2, that's a 0. Then what we can do is we can start the synthetic division process to hopefully get it down to some type of equation that we can factor. So I'm going to take the 0 that they're giving me of -2, and I'm going to start the synthetic division process. So again, I'll line up the 1, -13, 24, and 108. I better get a remainder of what? 0. So again, when I start the synthetic division, I have my 1. -2 times 1 is -2. -13 minus 2 is -15. -2 times -15 is 30. 24 plus 30 is going to give me 54. And then -2 times 54 is -108. So I do get a remainder of 0. So how does this help me? Remember, the directions just want me to factor. That's what I'm trying to do. So if -2 is my 0, what factor did -2 come from? -2 had to come from the factor of what? X plus 2 times. Remember, I've taken my x plus 2 and I've divided it out. So what I have here are the coefficients for the next polynomial. So I need to drop this down a degree, so I'm going to have a 1x squared minus 15x plus 54. So you take these numbers that you get at the bottom of your synthetic division. These are now the coefficients for that next polynomial. This is that depressed equation I was talking about back a few minutes ago. That's that depressed equation. The object is you want to do your synthetic division to hopefully get this equation down to something you can factor using your old techniques. So the question is, can I factor this? Are there factors of 54 that add together give me -15? Yeah, what would it be? 9 and 6, exactly. So x plus 2, is it going to be plus 9 plus 6 or -9 minus -9 -6? -9 -6. So there's your factorization. Again, first step is the factor. Before you can start solving these polynomial equations, you have to get them in factored form. Any questions on part A on how I started the fact? Again, the key is, as long as you know 1 0, you can start the synthetic division process and start breaking down this equation. Let's take a look at this next example. Again, just looking at this, I know grouping wasn't going to work. I know by grouping these last 2 terms together, I can't factor out a -16 and get a coefficient of 1. So I'm going to have to use the 0 that they're giving me. They're giving me a 0 of 6. So I'm going to start synthetic division. Line up my coefficients, 1, -3, -16, -12. So do my synthetic division, bring down the 1, 6 times 1 is 6, -3 plus 6 is 3, 3 times 6 is 18, -16 plus 18 is 2, 6 times 2 is 12, and I get a remainder of 0. If you don't get a remainder of 0 and they give you a 0, you know you've done something wrong. So now what we can do is we can start putting this in factored form. If 6 is my 0, what factor did 6 come from? 6 came from a factor of what? X minus 6. Again, I've started with an x to the third, so my next set of parentheses, I'm going to start with a 1x squared plus 3x plus 2. Again, the coefficients that you get after you do synthetic division are the coefficients of this trinomial. Hopefully, you can factor this some more. Can you factor x squared plus 3x plus 2? Yes. So then the complete factorization is going to be x minus 6 times x plus 2 times x plus 1. Because remember, eventually, we're going to start solving these equations. If you can get it into factored form, you then can start the solving process. So the first step is making sure you can factor. So let's take a look at C. Again, they're giving me my 0 of 2. So again, I'm going to put my 2 on the outside. Now be careful, in this particular case, you are going to have to put some placeholders. So again, my first coefficient is a 4. I've got a 0, negative 15, 0, negative 4. Bring down my 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. Negative 15 plus 16 is a 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4, and there's that remainder of 0. What factor did 2 come from? Start with the first factor, the 0 that they gave you. What factor did 2 come from? What factor did 2 come from? X minus 2. Remember, don't leave out that first factor. If I ask you to factor the polynomial, you can't leave off the factor that 2 came from. Times. I've started with an x to the fourth in my equation. What's this next set of parentheses? What's the highest exponent for x going to be? X to the third. So it's going to be a 4x to the third plus 8x squared plus x plus 2. If you knew another 0. Or, what type of factoring is going to work here? Grouping. So this, again, even though this is 4 terms, if you look, this actually will set up to be grouping very nicely. Because again, I can factor out a 4x squared out of the first 2 terms. That'll leave me with an x plus 2. When I group the last 2 terms together, pull out that 1, which would still give me an x plus 2. Remember, x minus 2 is just going to tag along to the final answer. So what's the rest of this going to look like? It's going to look like a what? 4x squared plus 1 times n x plus 2. Okay? So any questions on, again, the trick is, as long as you know 1, 0, then you're going to be able to get started on the synthetic division and do the factoring process. All right, any questions on if I give you a 0, how you can start the factorization? All right. So example 5, I'm still giving you a 0, but now I want you to find the other zeros. So now I'm having you take it one step further. You've got to first get it into factored form, so you have to factor first. Then you will set each factor equal to 0 and solve. Make sure you understand the difference in the questions that they're asking you for. Some of you guys will always solve, solve, solve. If I want it factored, you leave it with the parentheses. When I ask you to solve, that's where you would take it and set it equal to 0. So make sure you're reading the questions carefully and you give me what I want. All right? Or what the question wants, not what I want, but the question wants. All right? Those of you that take calculus next year, they are very picky. If you answer the question incorrectly, there's like no credit. So you've got to make sure, get in the habit of reading those questions carefully. If you solve and they want it just factored, there's no points. All right? So make sure you're in the habit of reading these questions carefully. All right. Well, the first thing we have to do is you've got to factor. None of my factoring techniques is going to work on this. I can already see grouping's not going to work. Yes? Equal to 0 and solve. Okay? So like I said, the first step is to factor. I'm giving you the 0 of 5. So I'm going to set the 5 outside my synthetic division box. I have 4, negative 9, negative 49, negative 30. So bring down the 4. 5 times 4 is 20. That's 11. 55, that's a 6. And then 5 times 6 is 30. So I do get a remainder of 0. So just like I did in the last example, what factor did 5 come from? 5 came from the factor of what? X minus 5. I've started with an x to the third, so I'm going to drop this down to a what? 4x squared. Okay. So any questions on what I've done so far? Now go ahead. You should be able to factor this. So go ahead and factor that 4x squared plus 11x plus 6. X plus 2. Any questions on how I factored it? Did I answer the question? No. What's the question actually want? It wants me to do what? Solve. So now that I have it factored, I'm going to go ahead and solve. So now I take each factor and set it equal to 0. So I'll take my x minus 5, set it equal to 0. 4x plus 3, set it equal to 0. X plus 2 and set it equal to 0. So my solutions are going to be what? Well, the 1 was given to me of 5. What are my other solutions? Negative 3 over 4 and negative 2. So any questions on once you get it factored, how you're going to solve these polynomial equations? Always check to see if your old techniques of factoring will work first before you have to go into the synthetic division. Because my next step is I'm going to pull that critical piece of information away from you. I'm going to pull away that 0 from you. So always check to make sure that old techniques of factoring doesn't work first. You guys go ahead and try B for me. Factor it, and questions, like I said, make sure you're reading the directions carefully. Understand the difference when they ask you to factor versus solve. Again, factoring, you leave your answers with the parentheses. You just leave them with the parentheses. Solving or finding your other zeros or roots, that's where you set each factor equal to 0. So make sure you're reading carefully and you answer the question accordingly. Any questions on if I give you a 0, how you can factor? All right? So now I'm taking that last piece, I'm taking that piece away from you because they're not always going to give you the 0. In fact, most of the times they're not. So remember, these are all similar questions in terms of how you answer. Find your zeros, find your roots in solving. It's all the same animal, it's all the same process. Or if you want to factor the process, you always start by factoring to solve anyway. So again, they want you to factor and then find the real zeros. So first of all, let's take a look at example 6a. They're not giving me a 0. Always check to see if your old factoring will work. Will grouping work here? Yes. So before you make it much harder than what it is, check to see if you can go ahead and do the grouping or some other factoring technique. What GCF can I pull out of here? I can pull out a what? 2x squared. And that's going to leave me with an x minus 2. No other GCF to pull out of this x minus 2 but a 1. So then I can factor this into 2x squared plus 1 times x minus 2. Again, this is your factored form. So any questions on how I factored? So now I'm going to solve. So I'm going to take 2x squared plus 1 and set it equal to 0. Take x minus 2 and set it equal to 0. Well, I'll do this easy one first. So what's the one solution going to be? X equals what? 2. So now when I subtract my 1 and I divide by 2, I have x squared equals negative 1/2. It exists, but is it real? No. So these are not real. These are going to be imaginary. The directions only want the real zeros. So the only real 0 I have to this particular polynomial is 2. Okay? The other two would be imaginary solutions. Okay? So any questions on that? Let's take a look at B. Will grouping work?
No.
No. So grouping's not going to work. And I'm not giving you a 0 to start the synthetic division process. This is where you're going to have to do your P over Q test. You've got to make your list of potential zeros. So if grouping doesn't work, if none of your old factoring techniques don't work, then what you're going to have to do is you have to create that list of possible real zeros. P, remember, is -4. It is your constant term. What are your factors of -4? The factors of -4 are what? Plus or minus 1, plus or minus 2, and then plus or minus 4. Q. Q is, remember, the factors of the leading coefficient, which is x to the third. What is the leading coefficient? 1. So again, the factors of 1 are just going to be what? Plus or minus 1. So then my list of potential zeros are going to be plus or minus 1, plus or minus 2, plus or minus 4. This is your worst case scenario. None of your original factoring works. I don't give you a 0 to give you that springboard to jump to right to synthetic division. You've got to now find, it's like you're going on a hunt. You've now got to find a 0 on your own. Remember, this is your list of potential real zeros. How do I know if a 0, I'm going to do synthetic division? I'm going to have to pick eeny, meeny, miny, mo from my list. Hopefully I'm lucky and I don't have to do this more than once or twice. How is synthetic division going to help me? What does that remainder have to be? It has to be a 0, exactly. Out of this list, what are the easiest numbers to work with? 1 or even -1. You have 1 and -1. So that's where I would start. That's where I would start. The object is you want to pick one that will give you a remainder of 0. So let's start with 1. Again, it's an eeny, meeny, miny, mo. You just pick a number. So again, when I do my synthetic division, I have 1, 6, 6, -4. So 1 times 1 is 1, 6 plus 1 is 7, 1 times 7 is 7, and I can tell right away, did I get lucky on the first try? No. So now, pick another one. What other number do you want to try? -1. So I have 1, 6, 6, -4. -1 times 1 is -1. 6 plus -1 is 5. -1 times 5 is -5. 6 plus -5 is 1. -1 times 1 is, did I get lucky again?
No.
No. What do you want to try next? 2. See if 2 works. Again, you keep doing this until you find one. Did you find it? Which one worked? -2. -2 worked, yeah. So think about what we did. So when we tried -2, you want to get this in factored form. So again, here's my 1. So there's my -2. So once you find your 0 that works, you want to write this in factored form. What factor did -2 come from? -2 came from the factor of what? X plus 2 times. Remember, these are my coefficients that go in the next set of my polynomial. I started with an x to the third, so what am I going to start in this trinomial? I'm going to start with an x to the second. Okay? So that's the factored form. Can I factor x squared plus 4x minus 2 anymore? No. Am I done? Did I answer everything they wanted me to do? No, because they wanted me to also find what? The real zeros. So unfortunately, I can't factor x squared plus 4x minus 2 anymore. So what I'm going to have to do is look at another technique of solving quadratics. I certainly wouldn't use quadratic formula. I would use that new lovely thing that you use, completing the square. So again, because remember, even though these may be irrational, they're still real zeros. So x squared plus 4x equals 2. Take 4, divide it by 2, and square it. So what am I going to add to both sides? 4. So I end up with 6 is equal to x plus 2 to the second. Then what? I'm going to do what to both sides? I'm going to take the square root. So x plus 2 equals plus or minus square root 6. So x equals negative 2 plus or minus square root 6. So you have one real rational solution of negative 2 plus these two irrational. Remember, not all your solutions are going to be nice, pretty whole numbers. They may be irrational. If you can't factor this quadratic, that's where you have to go down. That's why I put last night for homework some completing the square questions on there.
So,
yep. It is real. Yeah. Real, a real number classifies everything that's not imaginary. Irrational and rational numbers. Okay? The square root under negative. You guys go ahead. Let's, again, take a look at the last example. Will grouping work? Can I try this factoring by grouping? No. So I have to make my list of possible zeros first. I have to do my P over Q. What's P equal to? P is equal to what? 5. Q is equal to what? 1. So what are my factors of 5? My factors of 5 are what? Plus or minus 1, plus or minus 5. My factors of 1 are just going to be plus or minus 1. So my list of possible zeros is just going to be plus or minus 1, plus or minus 5. So go ahead and try. You are not able to factor that quadratic. That's where you have those other techniques of solving quadratic formula or completing the square. So I chose to take x squared plus 3x, and I'm going to complete the square, so I added 5. I took 3 divided by 2 and squared it, which gave me 9/4. So I added 5 to 9/4, which gave me 29 over 4. And then I did the square root. So the other two solutions besides the 1 was negative 3/2 plus or minus square root of 29 over 2. Okay? Yeah, you can make it all one denominator, yeah. So any questions, guys, on solving polynomials? Because that's the piece we really had.